So we folded those right to the center. Got it okay so far? Okay, I'm going to take my scissors and I'm going to cut. Kind of have to look under, but also at the same time, see where it says complex plane right here? I'm going to cut so it's right above that. So then when I open it, I can see where it says complex plane right there. Same thing on this side. I'm going to cut right above where it says complex conjugates. Okay, does that make sense? Any questions so far? Okay, I'm going to zoom in now so you can see just this top section. See where it says imaginary numbers? Imaginary numbers. The first thing we need to write right here on the front is I equals the square root of -1. If we had the square root of a negative number before, what did you say? What does even your calculator say if you put that in? The square root of a negative number. No real answer, right? There's no real answer. That's because there's not a real answer. There's an imaginary answer. Now, we're not doing imaginary math. This is a real study of math, okay? But it's called imaginary numbers, right? So open up just this top section right here. This is what we're talking about, okay? The imaginary unit, I, is defined as I equals the square root of -1. For example, if we have the square root of -4, remember how we could break square roots apart before? We're doing the same thing now, but we're breaking it up into -1 and 4. Well, what's the square root of -1? I. And what's the square root of 4? 2. So the answer is 2i. Before, when we did the square root of -45, we did the square root of 9 times 5, right? But now we're going to do -1 times 9 times 5. And why did I choose 9 and 5 and not like 3 and 15? Yeah, we know the square root of 9, don't we? Okay, so what's the square root of -1? I. What's the square root of 9? 3. And then what's the square root of 5? Yeah, I don't know either, right? Okay so far? Now here's something I need to caution you about. What's that mean? Caution. Be careful, right? Negative square root of 2 does not equal I square root of 2. Negative square root of 2 equals what? What does it actually equal? It just equals negative square root of 2. Where do we care about where the negative is? If it's inside, that's exactly right. If it's outside the square root, we know what to do with that. We've done it for a long time, right? But if our negative is inside the square root, that's when we get the I, the imaginary unit. Okay? Now look at this circle right here. This is something that's pretty interesting. Okay? Do you agree with me that I equals I? Is it okay for me to say that? Okay? Well, what's I times I? I squared, right? So I times I is I squared. Well, what does I equal again? Oh, you couldn't see that, sorry. I equals the square root of -1, right? What's the square root of -1 times the square root of -1? What do we have when we have two square roots that are exactly the same multiplied times each other? Like if we have the square root of 5 times the square root of 5, what does that actually equal? 5, right? Because it's the square root of 25, which we know is 5. So using that logic, what is the square root of negative 1 times the square root of negative 1? Negative 1. So I squared actually equals negative 1. Would you agree that I to the third is the same thing as I squared times I? Isn't that really I to the third? Well, what did we just say I squared equal? Well, what's negative 1 times I? Yeah, negative I, right? So I to the third is actually equal to negative I. Well, would you agree that I to the fourth is really I to the third times I? Right? And what did we just say that I to the third was? Negative I. Well, what's negative I times I? Negative I squared. And what's I squared equal to? Negative 1. So I have a negative 1, positive 1. So I to the fourth is really 1. Would you agree that I to the fourth is, sorry, I to the fifth is really I to the fourth times I? Well, what did I just say I to the fourth was? 1. So that's really 1 times I, which equals what? I. That's I to the fifth, right? So I to the fifth is really I. So I to the fifth is really I. Well, what do you think I to the sixth would be? And I to the seventh? And I to the eighth? And the ninth? And the 10th? And the 11th? You see why I have this drawn as a circle? Okay? Does that make sense? Any questions about the general unit I? We okay so far? Okay, let's go over to add and subtract complex numbers. Nope, I don't want to do that. I want to go down. Down to complex numbers a plus bi. Okay? Complex numbers are written in the form a plus bi. Now, complex numbers have two parts. That's why they're called complex. The word complex doesn't always mean difficult, does it? Complex can just mean more than one part, right? Okay? This A, this is the real part. Okay? And this B, this B, the BI part, is the imaginary part. That's what makes it a complex numbers, because there's two parts, a real part and an imaginary part. Okay? Now you can actually graph complex numbers. I know you're excited. Please try to calm down. Okay? If I'm graphing, but it's not like on a regular coordinate plane, is it? It's on something called the complex plane. This isn't the x-axis. This is the real number axis. What is this? The imaginary number axis, right? So if I am trying to graph the point 3, where do I go? Right 3. I don't go up or down any because there's only a real part, right? What about if I'm trying to graph 2i? Where am I going to go for that? Just up on this imaginary axis to 2i. So what if I'm trying to graph 2 minus 2i? 2 minus 2i. That's that point right there. And then if I'm trying to graph negative 1 minus 3i, so right there, right? Does that make sense? Okay. Do you see why this point is right here? 2 plus 3i. 2 plus 3i. Any questions? Okay. Now let's go to add and subtract complex numbers. And multiply. But add and subtract is first. Okay? Now normally when we add and subtract, especially if we're doing things with letters, right, where we're combining like terms. Well, it's the same kind of thing here. We combine real terms and we combine imaginary terms. Can we ever combine real terms and imaginary terms? Okay, so just making sure I understand. I can say, for this first example, what do I add? The 2 and the 3. Because 2 plus 3 is what? 5. And the reason I can add those two parts together are why? They are both real. Okay? What else can I add together? The i's. So 5i and a negative 2i. What's that? 3i. So I can't say this is 8i. So first of all, is I a variable?
No.
It is not, right? It is the imaginary unit. You're never going to see us using I as a variable because of the fact that I is the imaginary unit. We use X a lot, we use Y a lot, we use Z a lot, we even use R and things like that, right? We're not going to use I ever as a variable. But does I act like a variable sometimes? Yes, okay? Is there ever any time you can add real and imaginary? There's only two that I know of that are worth talking about. Space Jam and Who Framed Roger Rabbit. Are there any more?
I really like those movies.
But that's adding together real and imaginary, right? That's the only time it works. And you know I'm being silly, right? Because you know that's not math. That's just movies. Okay? But that's the only time you can add real and imaginary. In our class, we don't. Okay? So what about this one? This is subtraction, right? So what do I do here? 4 minus 2. 4 minus 2. What is 4 minus 2? 2. And then what is negative 3i minus negative 5i?
That's 2.
It is. It is plus 2i, isn't it? Because it's a minus and negative 5i, right? Okay so far? Now, what about multiplying? We're going to just continue to use the distributive properties just like we have in the past. Okay? So what is negative 10i times 2i? So negative 20, right? Because negative 10 times 2 is negative 20. And then I have I times I squared. What does I squared equal, though? Negative 1. So this number right here is actually negative 1. So what is negative 20 times negative 1? 20. Done. What do you think I should do with this problem right here?
Skip it.
We do not skip it. We distribute, right? So what's 2 times 3? Oh, yikes. Maybe it's just Monday morning? Is that what's happening?
Yeah.
6, okay. Then 2 times negative 5i.
Wait, it's not a variable.
So yeah, that's the thing. Can I combine like terms like adding or subtracting real and imaginary? No, I cannot. Can I multiply real and imaginary? Yes, I can. Okay? The only time I can't combine them is if I'm trying to add or subtract. But I'm not really combining, I'm multiplying here, and so we can do that. That's a good question though. Okay? So it's 2 times negative 5i.
Negative 10i.
Negative 10i. Okay? Now what is 3i times 3? 9i. And what is 3i times negative 5i? Negative 15i squared. Okay, so do you think I'm finished? No, why? Okay, first of all, I can do this, right? And what does that equal to? That's negative 1. So negative 15 times negative 1 is actually positive 15. And if I have a 15 and a 6, what does that equal? 21. Is that all I have to do? Well, I have 2 imaginary parts I can combine, right? Okay. Why didn't I just combine all 3 of these together? Yeah, I can't, because while it is not a variable, this is one of the places it's acting like a variable. You can't combine an I and an I squared. Does that make sense? Okay. So what is negative 10i plus 9i? Negative I. Now, why didn't I write negative I plus 21? Do you know? How are complex numbers written? Real plus imaginary. Okay? Is it wrong if you write negative I plus 21? No, it's not. Okay? But you know there's traditional mathematical ways we write things, right? We don't write x5. We write 5x, right? It's not wrong to write x5. It's just kind of goofy looking because we've always written 5x before. Okay? That's the same way here with complex numbers. We write the real part first and then the imaginary part. Does that make sense? Okay? Any questions about adding or multiplying? Okay, so what do you think's next? Dividing. But before we can talk about dividing, we have to talk about complex conjugates. Now, is this word new to you? Oh, it's not, right? We talked about it a couple weeks ago. Not in relation to imaginary numbers, right? But in relation to, we couldn't have a radical in the denominator, so we had to find a conjugate, right? The same way that we found that, we're going to find the complex conjugates of imaginary numbers, okay? So first of all, I will tell you, look, see how there's this blank right here? This is actually the start of the sentence, and this finishes the sentence. This that we're about to fill in are complex conjugates. Their sum is a real number, and their product is a real number. A plus BI. If that's the complex number I give you, what do you think is its conjugate? Think about a couple of days ago when we talked about conjugates to get rid of radicals in the denominator. What did we do to the radical? Made it negative, right? We changed the sign. So if A plus BI is 1, what's the other one? Perfect. So A plus BI and A minus BI are complex conjugates. Their sum is a real number and their product is a real number. Why is their sum a real number? Well, what's A plus A? Try it. Try again. 2A. What's BI plus negative BI? 0. So there's no imaginary part. All that's left is a real part, right? The same thing would happen as if I found their product. Think about if we distributed, the middle 2 terms would be I numbers, and the last term would be an I squared number, but the I squared would go to a real number because I squared is equal to negative 1. But because these are opposites, that middle term would go to 0, wouldn't it? Just like it did when we were multiplying with the radicals, the radical conjugates. Remember that? Okay? So here's some examples. We'll start right here. Write the complex conjugate of 8 plus 5i. What's the conjugate of that? 8 minus 5i. What's the conjugate of 4 plus 3i? 4 minus 3i. Oh, it's already minus though. Oh, so it's plus, right? If it starts negative, then to get the conjugate, we change the sign of the imaginary part, right? Okay. What about 6? What's the complex conjugate of 6? What do I do with the real part? Keep it the same. So what's the complex conjugate of 6? 6. That's kind of a trick, isn't it? Okay. Oh, this is almost always my favorite problem. You know why? It was my nickname growing up. Yeah. 4i. Yeah. What is the complex conjugate of this?
4i.
Negative 4i. Now I had to know this to be able to do this. Okay? When dividing complex numbers, when you simplify a complex number in the denominator, you have to multiply by 1. Okay? You cannot leave i's in the denominator. Now multiplying by 1, think back to when we did this a couple days ago with radicals. How did we decide what number 1 to choose? I chose the conjugate of the denominator and multiplied both numerator and denominator by that number, right? So the 1 that we're going to choose is the conjugate of the denominator divided by the conjugate of the denominator. If I divide anything by 1, isn't it just itself? Yes? Can I say that again? What I said was right, it's not what I meant. Dividing anything by 1 is itself, but if I'm dividing something by itself, what does that equal? 1. Okay? So if my problem says 7 over 3i, first I have to decide on the conjugate of my denominator. What's the conjugate of my denominator? Negative 3i. And then I'm going to multiply both numerator and denominator by that conjugate. Because isn't the value of this fraction 1? Yes, okay. So what do I get in the numerator? Well, I've got, it's a multiplication problem, right? Negative 21i over what? What's 3 times negative 3? Very good. Negative 9i squared. But what's I squared equal? Negative 1. So it's negative 21i over 9. So why would you lose points for that answer? It's not. It's not simplified. How would I simplify it? What are they both divisible by, numerator and denominator? 3. Okay. So what would I get? Negative 7i over 3. Very good. Okay. Okay. Now what about this problem? 6 plus 4i over 2 minus I. What do we do first? Decide on our conjugate, right? Actually, what we do first is don't panic. And then second, decide on our conjugate. What is it? 2 plus I. Very good. Now I multiply numerator and denominator by 2 plus I. Okay? Now I distribute, right? What is 6 times 2? 12. What is 6 times I? 6i. What is, 6 times I is just 6i. There's no other I. There's only one I. 6 times I is just 6i, right? Okay. What is 4i times 2?
8i.
8i. And what is 4i times I?
4i
That's 4i squared, right? So 4i squared. What about the denominator? What's 2 times 2? 4. What's 2 times I? 2i. What is negative I times 2? Negative 2i. And what is negative I times I? Negative I squared. Very good. Okay? Now let's simplify. In the numerator, I've got this I squared right here, which actually equals what? Negative 1. So I've got a negative 1 times 4, which is what?
Negative 4.
So I have negative 4 and 12.
8.
So 8. Then I have 6i plus 8i. 14i. And then in the denominator, I have right here a negative 1, right? So I have a negative 1.
No, it just makes it 1.
It's just 1. It's not I, right? It's just 1.
Okay.
And I have a 1 and a 4. 5. And then I have a 2i minus 2i. Yeah, that's 0, right? Now, isn't that what I needed to happen?
Yeah.
That's why I chose the conjugate, because I needed that to be gone, because I'm not allowed to have i's in the denominator, right? Okay? Any questions about this? Are you comfortable with adding and subtracting?
Yes.
Are you comfortable with multiplying?
Yes.
Good, because we did more multiplying down here, didn't we? Are you comfortable finding conjugates? Are you comfortable dividing? All right, now let me show you something. Because you know how I feel about the calculator, right? If we can use it, we're going to use it, right? But I also need to be clear that on quizzes and tests, you always have to show your work, right? Okay? So the first problem we did was this one, right? So I'm going to say 2 plus 5i. Did you see what I used? Did I use this I? No. This I is a variable. This I, do you see how this I is bold? You see that? Okay, so I'll do it slower when I do the next one. Plus 3 minus 2. Look where I went. Right here. The pi button. When I press the pi button, this menu opens and I choose that I. That's the imaginary number. Not the variable. The imaginary number. 5 plus 3i. Oh, look what we got. 5 plus 3i. Negative 10i. God bless you. Times 2i. Oh, look. We got 20. The calculator got 20. Those are all pretty straightforward. You could probably do these no problem with without a calculator, right? Okay? But look at this. 2 plus 3i times 3 minus 5i. That was a lot faster, wasn't it? So if this problem is on the test right here, and you put 20 minus I, what's going to happen? Yes, it will. Okay? Why? Why am I not going to give you full credit for that problem? You didn't show your work. Okay? You know the rule, right? So why am I showing you that you can do it in the calculator if I'm still making you show your work? You can check your answers, right? You should not get any of these wrong because you can check. And if something's wrong with your work, I can see that, right? I can see when you're making up work just to get an answer. So make sure your work is correct also, okay? Where it really comes as very helpful, because most of you guys are pretty good at multiplication, where it really becomes helpful is in the dividing, okay? 6 plus 4i over 2 minus I. Did I get the same thing? 8 plus 14i over 5. 8 over 5 plus 14 over 5i. It's not weird. This one is written in real plus imaginary form, right? This one we just simplified exactly as it was. So, am I going to know if you just plugged it straight in the calculator?
Yeah.
Yes? First of all, you probably won't have any work. And it'll be obvious, right? So why would I show you how to do it in the calculator? Yes, you can check. You know it's my job to teach you how to use the calculator too, right? That's in my TEKS. Not just to teach you the math. Yes, I'm going to teach you the math. And anytime I know how to do it in the calculator, I'm going to teach it to you in the calculator because that's required. If you look up there and read some of that stuff, it'll say the math and the technology. Right? Okay? So, yes, I'm helping you, but I'm also doing my job. Does that make sense? Okay? So let's do some really quick examples that are very similar to these ones in the beginning. Right here. Oops. Sorry. These. I just want to make sure that we are all on the same page with this to make sure you understand. Okay? Square root of negative 12. Remember, I can, because of rules of radicals, I can break that into two parts like this. Remember that? Why did I choose 4 and 3 and not 2 and 6? You know the square root of 4, right? You don't know the square root of 2 or 6. Now I don't know the square root of 3, but at least there's something I know the square root of, right? So what's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 3? I don't know either, right? What is the square root of negative 75? Negative 1 times 25 times 3. What's the square root of negative 1? I. What's the square root of 25? How about if I tell you the answer as I'm asking you the question? Okay. 5. And what's the square root of 3? Still don't know. I don't know. Okay. Now I'm going to try to trick you. Are you ready? Negative square root of negative 26. That's a tricky one, right? Because what do I do with this negative out here? Yeah, just ignore it, right? I just bring it down. What's the square root of negative 1? I. What's the square root of 26? The only thing I can think of that divides into 26 is 2 and 13. Do I know the square root of 2? Do I know the square root of 13? No, so just leave it. Almost 6. Does that make sense? I didn't even trick you. Dang it. Any questions on any of this stuff? Good? If you start your work and you suddenly have a question, yeah, ask. Okay?